Hi, good morning to everyone. I'm Eduard FoschVillaronga, and I am currently working at Leiden University as a Marie Curie postdoc, a researcher working on the legal and regulatory aspects of robot technology. And I'm very thankful for the invitation to be able to talk today at COVR Open Day. My presentation is about the possibility to link robot development and policymaking in order to help update the policies and standards that we have in order to reflect truly the nature of current robot technology. There are some initiatives that they are trying to help make the compliance with the regulatory framework in an easier way. One of them is COVR, and COVR does an amazing job into trying to understand how the regulatory framework surrounding robot technology can be presented to robot developers in an easier and in a much more practical way, so that the compliance process that they have, it is much quicker and much more effective. There are also other initiatives in the US. For instance, there is one initiative called the Regulatory Robot. It's not for robot technology, it's for products. But one of the good things about that system is that it is a tool that actually helps producers identify which are the regulations that they need to apply for their specific product. As they say in their website, as more products are unique, each product may need to comply with different requirements. So you'll need to run the robot one time for each product. I do believe the same, that robot technology differs largely because of many different aspects, including embodiment and capabilities, and also what is the context of use and the intended users. So a myriad of regulations may already apply to this robot technology, and developers usually struggle to understand which regulations apply and to what extent to their specific case. Some of these regulations are also technology neutral, so it's very difficult to understand how these vague regulations apply to specific cases. And having different tools as a COVR toolkit can be of help. The problem of these tools is that they only reflect what it is the juridical and the standard knowledge that we have right now. So new applications might not fit into existing robot categories. And it may be also possible that the legislation might be outdated, and that it does not truly reflect how robots work right now. When we think about products, for instance, that they weren't used to be connected to the internet, but now they are connected and they talk to each other. Some of these products as robots, they may be meant to interact with each other. So by separating the robot from the human operated, as traditional safety standards have been addressing safety issues, is no longer applicable in the case of service robotics or collaborative robots that they are going to be working with us. And a lot of the times, these pieces of legislation also include confusing categories. So for instance, the standard ISO 13482 2014 on personal care robots, they exclude medical devices, but they include as categories wheeled passenger carriers that remind of wheelchairs, but they are not really medical devices. And they also have physical assistant robots, which are exoskeletons that can be lower or upper limb, and those would be for rehabilitation and considered medical devices. But still, you see also that the industry is pushing for an in-between category that the law does not really reflect. So all these confusions actually challenge a lot how we can ensure compliance when the regulatory system is not also updated to these new developments. And I'm going to give you one practical case. Even if, of course, if you are a developer, you might have experienced that on yourself. Some researchers developed a door-to-door garbage collector because they realized that in some cities that they are very old, the trucks that they collect the garbage cannot fit into the small and narrow streets of the cities. So they decided to develop such a robot in a European project. What they realized is that user acceptance was all right, like everyone was on board into it, and that the robot was working fine, also autonomously, so the technology also was not a problem. The main problem that they had was actually the regulation. So the regulation was a problem. And why was that? The researchers tried to put that robot into the streets of Peccioli, and the municipality opposed to that because they didn't see the robot as any of the categories of things that they can be in the streets. So they were not a car, they were not a van, they were not a truck, they were not a bicycle, and they were not an animal. They were not even pedestrians. And on the top of that, that robot was working autonomously, whereas the legislations that we have for road traffic include that there's the need to have a driver for the vehicle to be in the street. So the municipality at first opposed to the deployment of such robot into the street. After engaging with some discussions with the policymakers, what they got to do is to somehow meet halfway the researchers. And what they did is to include the testing site non-pedestrian area. And they included 3 different streets and also a square. They limited the experimentation to 8 a.m. to 8 p.m. every day of the week, except Wednesday for the local market. Of course, this is Italy. And even if the robot was working autonomously, they asked them to draw a yellow robot lane to indicate the robot path. They included different cameras, and at the same time, they were asked to have ad hoc road signs in order to highlight that they were actually conducting the experiment. This case illuminates various ideas. First of all, the law is not always prepared to accommodate new technological developments, especially if these advance exponentially. And we see that robot technology push the boundaries of what was possible before and what is possible now. That a formal communication process between regulators and robot developers is currently lacking. So there's a lot of different ways in order to conduct policy making in the public level and also the private level. But when it comes to these small cases, it is not very clear what is the process that any other researcher in Italy, in this case, or in Europe, would have to follow in order to include one of these robots into the streets of a certain municipality. Also, what this shows is that the regulator might be also willing to meet the researchers halfway in a pro-innovatio manner, and they might be willing to accommodate to certain requirements because even if the law, as we said, didn't envisage to have a category as a robot in the streets, there was no apparent reason for opposing to that because it was not creating any greater danger than any other vehicle would put in that situation. And also the other idea that highlights is that the documentation of all this process could be collected in a data repository and serve as evidence for future policies. So if we could set this example as a precedent, then any other researcher working on a similar type of project, like putting a category that does not exist into the streets, could follow a similar process so that we could speed the approval for that to happen, but at the same time to establish some sort of safeguard baseline that other researchers can follow. And this is a very small example that happens here, but then this also can be applied to many different robot technology. We see it with autistic children and robot therapies. Every different research center is developing their own solutions, and they're trying to accommodate the different needs from the users, the hospitals, and the nurses and the parents in certain ways. But it is not very clear like how we could standardize such a process, and how can then the law reflect these advances of robot technology. And I'm sure that you can think about a moment where you felt that the law was somehow impeding something that you are developing at your center, but at the same time you felt that that was something somehow ridiculous, because actually that could well be also reflected into the legislation, but because of that you had an impediment. So acknowledging the need for an issue manager, there's some part of the literature that focuses on the creation of governance coordinating committees for the governance of emerging technologies like AI and robotics. And the European Union focused on creating the European Agency for Robots and Artificial Intelligence that was proposed in 2017, and there hasn't been great advancement in this area. And also in the US, we've seen different examples that have been pushing towards having an agency that is exclusively dedicated to work for emerging robot technology. So what me and Michiel Helleberg from University of Twente thought when we were addressing this topic is that actually what lacks in robot governance is a backstep mechanism that could coordinate and align robot and regulatory development, because we see that although both aspects, the robots and the law, evolve, they evolve at different speeds and in different directions. And sometimes there is a miscommunication between these two. So what I'm here presenting today, it is something that you can read extensively in two major publications that we did. The one is Regulation I Presume, Said the Robot in Computer Law Security Review. And the second one, it's a shorter version of it that it's called Meet Me Halfway, Set the Robot to the Regulation, linking ex-ante technology impact assessment to legislative ex-post evaluations via shared data repositories. So what we propose in our research, it is actually an iterative learning governance process. So what we see is that connecting the idea of the first examples from the COVR toolkit or the regulatory robot, we see a very important advancement into the understanding of how we could create personalized regulatory models for specific robot technology, so that each robot developer could know how to comply with the robot, with the legal framework for their specific case. So that would be one step. But what we see is that that is just one of the steps. Like, we need something that we could collect information from the inconsistencies that exist in the current legal and regulatory framework, so that then slowly we can update this system. So we call it iterative because we believe that it shouldn't be static. So this would be like the beginning of what we would conceive as a dynamic regulation, and learning because it's actually learning from specific cases and in a bottom-up approach, because normally what it happens is that the legal analysis, it's all normally top-down. So like the law says A, and then we see whether our robot fits or not. But actually what we want to do is to reverse this and look it from the bottom-up perspective. And I'm going to show you how it looks. So basically the model looks like this. So basically we would start with the creation of a robot, and then there would be like a decision whether there is a positive and a clear legal fit or a negative fit response. But then also this would connect to the law and in a different way. So I assume that your face is a bit like this because it's very cumbersome, but I welcome you all to read the first paper where we explain the model. And here I'm going to break it down for you in order to make it a little bit more visually attractive. So the idea is to start the assessment of a robot from robot impact assessment. So the idea is that robot developers could describe the context of the robot, where it is going to be used, the human-robot interaction, and the technological context. And so describe also what is the robot that they are going to use and what are the characteristics of this robot, whether it works autonomously or not, and so. And then check whether robot complies with existing legal framework. And this would be more or less where the COVR toolkit enters. So the use of compliance tools in order to understand whether we are compliant or not. But the idea that we have is that we could connect that with the questions of whether these legal frameworks suffice or it doesn't. And there are like some inconsistencies that doesn't prevent us from going with our development. And also to understand how the developers overcome such challenges, and how or what did they do in order to accommodate to the regulatory framework. So the idea is to collect all these lessons learned from the different developers in what we call a shared data repository. So where we could have a database of different robot impact assessments and try to collect different matches from different types of robots and different types of risk and mitigations with the current legislation. By doing that, somehow we could advance already the understanding on how different types of robots comply with different regulations. So then everyone that is working, for instance, in an exoskeleton would know what are the main challenges that they found, and then how they mitigated them in order to comply with the legal system. But also, and not only that, the idea is to use the shared data repository as a sort of data generator for policy purposes. So the idea is to somehow connect the collection of these misfits, these inconsistencies with the legislation, and to redirect it to the relevant policymaker. And this policymaker can be many various types of policymakers, because it could be the municipality, as we see, or the region, or the central government at the European level, for instance, or private standard bodies. Then somehow it could be the fact of releasing guidelines from time to time and support from the evidence of the shared data repository. And the idea is to focus on learning and an evidence utilization understanding of legislative evaluation mechanisms in order to close this combined top-down, bottom-up model by including the regulatory framework, all the new modifications that we've been having. And that is the basis of what we want to do for the project LIAISON. We have applied for a COVR award. So in the COVR award, we are not going to do the full model, but we're just like going to focus on a particular part of this model. So the idea is like to extract compliance and technical knowledge from compliance tools as the COVR toolkit, and direct it to policymakers to unravel an optimal regulatory framing that could include change, revise, or interpret for existing and emerging robot technology. And what we believe is that this process will bring clarity to what regulatory actions policymakers have to take to provide compliance guidance, also explain and clear concepts or uncertain applicability domains to improve legal certainty, and inform future regulatory developments for robot technology use and development at the different levels. We believe that this is novel because some part of the literature reflects on the consequences of how R&D can, of the responsible research innovation can influence the design process of the robots, but how these considerations can improve existing regulatory instruments has yet to be reflected into the literature and also to happen. So not only the focus on how the law or the ethics can influence the robot development, but how the robot development could influence the legislation in order to update them. So our project is going to be innovative because it takes the lead in this challenge, and it investigates how we can generate useful knowledge from compliance tools as the COVR toolkit and redirect it to relevant policymakers to facilitate adequate regulatory action for better robot governance. So time's up. Thank you so much for listening today. If you have any questions, I would very much like to address them. You can drop me an email, or if you are curious to know more, you can also be in touch. So thank you so much, and I hope that we can be in touch soon.